All right, with this lesson, you are going to learn something that once you do, the world will seem brighter. You're going to look out and be like, I know these things now. And you're not going to be able to unknow them because that's how amazing the quadratic formula is. So let's delve right into it. Again, we are learning ways to solve a quadratic equation, and the beauty of this method is it works no matter what. So, goal number 1, you need it set equal to 0. This is important, and it's something that we'll check for every time we do a problem using the quadratic formula. However, just like with some other items from this chapter, we are going to also note that it is important to know A, B, and C, because they become, or they have a place within our formula. All right, so here it is. And there's a song, so let's write it out first, and then I will sing the song for you. So to solve, obviously, we're looking for the values where y is 0. So the answer is we're looking for x, so it starts as x equals, and then I'm going to draw a giant fraction bar in here. So let's work on the numerator portion of this. First, we would say, and you can say negative b or opposite of b. I prefer to say opposite of b. So we have the opposite of b, plus or minus, that's how we get to those two solutions. Then we have the square root of, and it's a pretty long radical. We're going to take b and we're going to square it. I'm putting parentheses as a reminder. When b is negative, when you square it, it should become positive. And one of the biggest mistakes made is that people do not use these parentheses, thus they get the wrong values because their calculator doesn't understand that the negative also needs to be squared. So these parentheses are very, very, very important. So we have b squared minus 4 times a times c. There's our numerator, all over 2 times a. And that is the quadratic formula. Now over here it has this caveat. A can't be 0, meaning it has to be a quadratic. And for it to have a solution, this portion, which I'm going to give a name here in a second, has to be greater than or equal to 0. Again, in Algebra 2, you'll figure out what happens when that's not the case. Now, this portion here is called the discriminant. I'm going to kind of put that name over here on the side. And we will review this part when we get to the end of this set of notes, the discriminant. All right, so I'm going to sing the song. If we were taking these notes in person, you probably would record this part just so you could memorize it. And I'll try to sing it a couple times to maybe kind of get stuck in your head so you kind of remember it. So it goes, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So it kind of goes along with our Pop Goes the Weasel tune. All right, if you wanted to rewind that and sing it with it, feel free. So, solving using the quadratic formula. First, so important, is it set equal to 0? The reason this is important is because we need the values of a, b, and c to be accurate, and that means that these that they're on the correct side of the equation, because that could affect their sign. All right, so once we're there, it's kind of a 3-step process, which I know kind of simplifies it out. But first we need to identify A, B, and C so that we can place them in the right spots. Then we will substitute. Then our goal is just to be able to simplify, whether we're leaving it exact or we're taking it all the way down to an approximate answer. All right, so A, always located in front of our x squared term, and it is just the number, not the x squared. So A in this particular case is 3. Hopefully you're pretty good at this by now. Most of you got it right on your quiz. All right, our b term, always located in front of x. In this particular case, it is 5. And then last but not least, our c term, or the value that doesn't have a variable, which in this particular case is -8. All right, so let's sub the stuff in. So we say x equals the opposite of b. I'm going to pause there. So opposite of b would be the opposite of a +5. So I'm going to say -5. I'm going to use my magnifying glass so I don't have to keep zooming in and out. There we go. Plus or minus the square root of b squared, 5 squared. Now in this particular case, the parentheses are technically unnecessary because of the fact that 5 was positive to begin with, but it's not a bad idea just to keep using them until you're very aware of when they are and are not necessary. So b squared minus 4ac. So we have 4 times a, which is 3, times c, which is a -8. All over 2a. So 2 times 3. There's our quadratic formula. Now we just simplify, which is sometimes trickier than you may think. We're going to kind of simplify it using order of operations. If you think of PEMDAS, parentheses are there at the top, and what kind of happens, you'll even notice it when you use a radical or a square root in your calculator, it automatically opens up a set of parentheses, meaning what's under the radical is usually a good place to start. So as we start to simplify this, I'm just going to copy and paste mine. I usually start with under the radical, and then we can go ahead and multiply that denominator as well. So let me change colors here. So we want to go and do this easy one down here. 2 times 3 is just 6. I like to enter just the underneath portion, and I'll explain that why here in a second, because it tells us a lot of information. So if we do just this underneath, we call it the radicand. It's the part under the radical. And in your calculator, you put 5 squared minus 4 times 3 times the -8. You should end up with 121. Six goes down here. And our -5, it just kind of hangs out till the very end when we determine if we need to use it for simplifying or if it just stays if we're leaving it as an exact answer. Now, that discriminant tells us one thing. Since 121 is a perfect square, that one means we're going to have two solutions, and they're going to be nice. They're going to be nicer. We're going to be able to solve this all the way to the end. We won't get like an approximate decimal. We won't get an, I shouldn't say, we shouldn't get an irrational number. We will get a decimal potentially, but it will be rational. This 121 also tells me, and we're going to discuss this again at the end, that this problem could have been factorable. So once we know all the ways to solve a quadratic, the question becomes, how do I know which method to use and when? One of the ways to determine if factoring is what you would like to do or not is to use the discriminant, which is this 121, to determine if factoring is even an option. So when you do the discriminant and you get a perfect square, that means factoring could have been used to solve the problem. You didn't have to use the quadratic formula. All right, so let's keep simplifying. We have -5 plus or minus square root of 121 is 11. Oops, I probably should keep my color coding going. All over 6. Now, the plus or minus is what gives us our two solutions. So we're going to do this in two separate fractions, one with the plus and one with the minus. Now, if you don't tell your calculator that this is a fraction it is going to do the division of the 11 and the 6 first. So depending on which calculator you're using, you may want to put parentheses around your numerator. If you have a calculator that lets you physically write as a fraction, it shouldn't be a problem as long as -5 and 11 are in the top. Just be very careful that you make sure you get the right answers. And maybe it's not a bad idea to pull your calculator out now and just test it to make sure you get the following answers. So for this one, we should just get 1. And for this answer, we should get 8/3, which is still a decimal, but it's a rational number. And if you wanted to write that 8/3 as a decimal, you could have 2.67 if you wanted to round to the nearest hundredth. So that is how you solve using the quadratic formula. Some people, once they know that this works every time, they prefer to do this every time. The goal of the other methods that we have covered so far is that sometimes they can be faster. And since we're eventually prepping you for things like the ACT, we would like you to be able to complete things in a timely manner. And we're trying to find that happy balance between understanding and efficiency. And so sometimes using the quadratic formula every time can be a slow process. Whereas if you are able to use other methods, it can quicken it. All right, so we're going to do this one more time together, and then obviously you have some in your homework to do. If you would like to pause at this point and try this one, or at least get it started, maybe do the identify and the substitute step on your own, feel free, and then watch it to make sure you got everything in the right spot. All right, so technically step 1, before we identify A, B, and C, this is part of that, we want to make sure it's a set equal to 0, which this one is not. So before we determine A, B, and C, we need to move everything to the left. So in this particular case, I'm going to subtract x to the other side so that our quadratic is indeed in standard form. So we are now set equal to 0. A is 2, B is a -1, and C is a -7. All right, so I'm going to go ahead and copy and paste my quadratic formula down here. Or, you can sing the song. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So let me put my B's in first since they show up first. So B was a -1, which means when we go opposite of a -1, it's actually going to be a +1. That's why I like to say opposite instead of negative, so you don't think it has to be negative. It's just the opposite of whatever B was. Since B was negative, it's actually positive. This is why the parentheses are nice here, because this is a -1, so the squared should take care of that negative. So there's where our B's go. All right, let's go ahead and plug in our A's, which was 2. And then last but not least, plug in our C, which is a -7. Now, some of you might feel inclined to type this whole thing into the calculator at once, which you can, especially if it'll leave it in simplified form for you. Just make sure you're very careful about getting everything in the right spot. So we have 1. So remember, this one just kind of chills until it knows what it can do next. Plus or minus. This radicand ends up being 57. I'm going to put that in a different color here. And then 2 times 2 in the bottom is 4. All right, so 57. We still have 2 solutions because it's positive. However, 57 tells us our answers are going to be irrational. They're going to be decimals that we're going to have to round. 57 also tells us that we would not have been able to factor this problem to solve it. So again, that discriminant, this number that's underneath, it can tell us a lot about the number of solutions to a problem, but also what methods are available for us to use. Now, technically, since 57 doesn't simplify, this could just be your answer. So if you choose to leave things as exact answers, this is as far as this problem goes. The square root of 57 does not simplify, so if you wanted to leave it as an exact answer, you could, and it would look just like this. You'll notice when you do your Khan Academy, this is how Khan writes the answers. So it's not a bad idea to kind of keep that in mind so that you can finish your Khan in a timely manner. However, for your homework, if you would prefer the approximated answer, you would need to evaluate this for both situations. So I'm going to go ahead and swap over to my Desmos so we can look at what that would look like potentially. So if I want to know, I'm going to go ahead and use parentheses so my calculator knows what's in the numerator. So I'm going to go 1 plus the square root of 57 divided by, so it's very important, my calculator either writes it as a fraction or I put parentheses so it knows that is all in the numerator, and we're going to put over 4. That should give us approximately, and we're going nearest hundredth, 2.14. So that would be the first of my solutions if I went with an approximate answer. Then I go back over here, and all I need out now is I need to make it a 1 minus. So again, there's no plus or minus button. You have to do them separately. And there we should get a negative 1.64. So you could also write your answer here. And you'll notice on the answer keys that we have it stated as a or situation. So one or the other, depending on where you'd prefer to leave it. So this is the approximate answer. All right, which takes us to our last piece. Sorry, left out a P here. Let's take this to our last part. We still have one method to go, and we're going to learn it next week. However, as you start solving and reviewing and or when you take the quiz this Friday, you might start thinking about what method works best. Up to this point, we've kind of dictated, hey, use this to solve, use this to solve, use this to solve. So on the quiz last week, you used graphing to solve, and you used factoring to solve. But we would like you to have some intuition about what method is best as you move forward. So how can we tell which methods are the preferred method? So let's start identifying which method could work. So as discussed potentially, I don't know if I said it, but quadratic formula works no matter what. So for all of these options, A, B, and C, you could write the quadratic formula. However, I'm going to only write it if it's absolutely necessary. So let's go back through our options. First, from last week was solving by square roots. Something we determined is that to solve by square roots, we either have to have a quantity squared, which we do not have here, or our bx term has to be missing. So if A, B, and C, which one has a bx term missing? That would be A. So something to look for if you would like to solve by square roots is that the bx term isn't there. Technically, it's a 0. This would mean that square roots is an option. And you'll notice there's a part of your homework where you're doing this type of analysis. So we want you guys to really practice that so you can start kind of figuring out your options. All right, none of the rest of these will work for square roots. This one only has 2 terms in it, but it does have the bx terms, so square roots won't work. However, you'll notice that these 2 terms both have a GCF of x, which means for this particular one, you could factor. So one of the items you're looking for to know if factoring is an option is a greatest common factor. And as discussed up in example 1, you could also be looking for a discriminant that's a perfect square. So this would also tell you something was factorable. However, it is not always obvious that something is factorable when you initially just look at it. So, as I mentioned at the beginning and we kind of kept talking about, if you just do this portion of the quadratic formula, it should tell you if something can or cannot be factored. So if you are a big fan of factoring and you would like to know if it is an option and it's not very obvious to tell, this is something you can use. So if you wanted to write this in, this is how we can determine if something is or is not factorable. So I'm going to go factorable question mark. So if you do that for this particular problem, you're going to get 161. So that would be the result of 9 squared minus 4 times 5 times a negative 4. You want this to be a perfect square if it is factorable. So the question becomes, is 161 a perfect square? So I'm going to put a question mark because that's what you're asking yourself. If that answer is a no, which it is here, if you're not sure if it's a perfect square, just take the square root of it. If it doesn't give you a whole number, then it is not. So if that answer is a no, that means the only other option that we know of at this point to solve is the quadratic formula. All right. That rounds out these notes.